In this video, we're going to cover part 3 of section 5.2. We're going to initially go with some properties of the integral. So as you can see, we have on the top defined some values for some integrals. We have the integral from f of x from 2 to 4, and that's going to be minus 4. And we have that the integral from 2 to 7 of f of x is going to be 4. And that the integral from 2 to 7 of g of x is going to be minus 8. Using the properties, we'll find out the following integrals. So the first is going to be the integral from 7 to 2 of g of x. Now notice that we have the opposite, and we can flip this around by doing a minus. So in the properties, this is just minus 2 to 7 of g of x dx. Now we do have information for this one. 2 to 7 of gx dx is minus 8, so this is going to be minus 8, and the result for this is just 8. So that's A. For B, we have the 4 to 7 of f of x dx. But we have 4 to 7. No, we do not have 4 to 7. But the way that we can do this is we can take the integral from 2 to 7 of f of x dx and subtract from 2 to 4 of f of x dx. That, remember, is like splitting the area. We have 2 to 7, and we're picking 4 here in the middle. So we might have all the area from 2 to 7. And what we do is we subtract 4 to 2, and when we do that, we're going to be remaining with 4 to 7. Okay. We do have the information for this. 2 to 7 is 4, and 2 to 4 is minus 4, which is going to give me this, and so the result is going to be 8. Now, one easy one is, if you recall the properties, the integral from a point to itself is going to be 0. So that is completely it. And finally, we can do the integral of 2 to 7 of f of x minus 6 times gx. And by the linear property of the integration, this is just the integral from 2 to 7 of f of x minus 6 times the integral from 2 to 7 of g of x dx. We know who is each of these cases. 2 to 7 we know is 4 for f of x, and we know that 2 to 7 for g of x is just essentially minus 8. So this is going to be 4 plus, and 6 by 8 is 48. Minus and minus plus. So we have that this is 52. Okay. So a little bit of toying with the properties of the integrals. Now let's go and do another example of working with areas. And on this occasion, we're going to have the areas to be really clear. They're going to be given by the function x sine of x, and we're going to have 4 different regions here, and the area is going to be marked. If you notice here, R1 is area 1, area 2 is pi minus 1, area 3 measures pi plus 1, area 4 measures 2 pi minus 1. So with that, we're going to be able to find the following integrals. So the first is going to be the integral from 0 to pi of x sine of x. So we just need to be able to tell what is involved in 0 to pi, and notice that this is 0 to pi half of sine of x sine of x dx plus pi half to pi of x sine of x. So this is essentially area R1 plus area R2. And so this is going to give me a 1, and this is going to give me a pi minus 1. So overall, the area will be pi. For b, we have from 3 pi half to 2 pi of x sine of x. So let's look here, the area from 3 pi half to 2 pi, we're only having the area given by R4. And because it's negative, we're going to have to put is below the x-axis. This area should be negative, or we should give a negative value to the to front of the area. The area itself is 2 pi minus 1, but since it's below the x-axis, we're going to put a minus to find the integral, and b is just going to be minus 2 pi minus 1. Now to finalize, if we do 0 to 2 pi of x sine of x, then we have all the areas coming into play, r1 plus r2 plus r3 plus r4, and so that's just going to be 1 plus pi minus 1, and then minus, because we have negative areas now, pi plus 1, and then minus 2 pi minus 1. We can simplify to obtain whatever the value is here. We have a pi here going on, and then we get a minus pi minus 1 from this, and we get a minus 2 pi plus 1 from here. 1 is going to be canceled with minus 1, and pi is going to cancel each other with minus pi. So we're going to end up with a minus 2 pi for the value of the full integral from 0 to 2 pi. And that's the end of the examples for this section.